Question 5, a crate supported by 2 ropes. Okay, so let's just draw this picture out. I'm going to assume you've already read it. We've got this box, and it says we're going to be supporting one rope at an angle of 48 degrees and 31 minutes. I would probably change to decimal. You don't have to do it this way, but I think that'll make it easier on you. So let's do that. Okay, it is at an angle with the horizontal. And the other rope is horizontal. The only way this is going to make sense is if it looks like that. So you've got 2 ropes, and I know this is kind of weird, but you got one at an angle and one at a horizontal. And those 2 ropes are vectors. You've got some force pulling this way. In fact, that force is what, 95.6 pounds? And the other force is pulling this way. So you've got 2 ropes, 2 vectors. Now, if you think about the 2 forces acting on the box, we can find the resulting force by drawing that parallelogram. The resulting force would be something like this. Okay, that's the resulting force, and that just so happens to be equal and opposite to the weight of the crate. So the resultant, the equilibrant, both would be the same thing. They would equal the weight of the crate. The box is pulling us down, but the ropes are holding us up. Those 2 forces have to be equal, and that would hold the box in one place. Okay. Now, when you look at this picture, hopefully a right triangle will jump out at you. I see this right triangle right here. And I don't have a lot of information inside that triangle, but because I know this is also a right triangle, I can just subtract off the 48 number and find that other number is about 42. Okay, so think about it there. We're going to do 90 minus 48.516, repeating. 41.483, repeating. 41.483 degrees, something like that. Okay, so if that's too busy for you, you can always redraw the triangle in question here. We've got this angle, 41.483 repeating degrees, and this hypotenuse is 95.6, and we want to find this side right here. So since this is a right triangle, we can treat this like a SOHCAHTOA problem. SOHCAHTOA, check it out. We've got the, looking at this angle, we've got the adjacent side and the hypotenuse. So that's going to be cosine. Adjacent over hypotenuse, like that. To solve, we're going to multiply to cancel out the 95.6. Okay, so it'll be 95.6 cosine 41.483, repeating. We get about 71.6. So the weight of the crate is about 71.6 pounds. Okay, that's the weight of the crate. That's the first part of this problem. The second part says the tension in the horizontal rope. So the tension in the horizontal rope means we want to find this magnitude. And so when I look at this problem, I see another right triangle. That is a right triangle. And because we just found the weight of the crate, this side is 71.6. That's good. And then also, if you notice the parallelogram, this side was 95.6, so that means this side is also 95.6. And looking at that right triangle, we know we can do the Pythagorean's theorem. Pythagorean's theorem is going to say x squared plus 71.6 squared equals 95.6 squared. So let's isolate the variable. We're going to subtract that over. 95.6 squared minus, I'll just use my answer button. Don't forget to square it. It's 4,010 and change. X squared is about 4,010 point something, but it doesn't matter because we're going to take a square root. Square root of that button, that answer, 63.3. X about 63.3 pounds. That is the tension of the horizontal rope. We've got the weight of the crate, tension of the rope. There you go.